Yo kids, this is 2022, excuse me, AS Physics Unit 1. This is now become the infamous question 3. It was worth 17 out of the 80 marks. 20% of the whole paper was dedicated to this question. Quite a few of those marks are bookwork, so it's stuff you just should have revised and learned off by heart before you got in there. The first question is an example of that. State Newton's third law of motion. For every action, there is an equal and opposite reaction. Learn it. Then there was a question about these equal and opposite reaction, Newton's third forces on the gravitational force of Earth on the drone. Literally, take these two words and swap them round. Okay, so the opposite to that is the gravitational force of the drone on the Earth. And then the forces of the rotors on the air. Literally swap these words for force of air on rotors. Of course, this one was vice versa. Question B says state the relationship between force and momentum. Now, of course, F equals ma, A is acceleration. A equals V minus U over T, which is the rate of change of velocity. If you multiply that by mass, you get the rate of change of momentum. So that's the relationship between force and momentum. Force is equal to the rate of change of momentum. mv minus mu all over t. And it tells us here that the drone produces an air speed of 22 meters per second when it's hovering. And there are 4 rotors producing the equal and opposite upward force to keep it stationary, okay? So they then tell us that the rate of change of momentum, now don't forget we've just defined that as force. So think force, newtons, mass times acceleration, all of those things got to be going through your head. The rate of change of momentum from the 4 rotors, that's in bold, so that's telling us the total can be expressed with this formula here, 4 pi r squared, r is the radius of the blades, rho is the density of air, which they're going to give us, and v is the velocity that the blades are spinning, okay? It says, show that the weight of the drone is approximately 20. Weight is a force. So all I got to do is chuck the numbers in there, because that's the formula for force. Chuck the numbers in there, and it should come out near 20, right? So 4 times pi times the radius squared. There's the radius, 5 times 10 to the minus 2 squared. Times the density, rho, 1.3. Check the units, kilograms per cubic meter. Don't change the 1.3. Times the velocity squared. They told us on the last page the velocity was 22 meters per second. Chuck all down the calculator, press the buttons, comes out as 19.8 newtons. Happy days, because they said approximately 20. It then says, calculate the vertical acceleration of the drone when v is increased to 24. Now, let's have a think about this. How do I get acceleration? Obviously, there's an option of suvats, but there's no indication in here of time or distance or displacement. So suvats is probably out. The other way to get acceleration, of course, is F equals ma. The resultant force is mass times acceleration. And they've given us a formula for force. So I think this is the route to go down. What I'm going to do, I'm going to work out the force with the new speed. I'm going to find the resultant force by working out the change in those two forces, divide through by the mass, and that will give me the acceleration. So when v is 24, put all the numbers back in here again, but use 24 instead of 22. So that's exactly what I did there. And it came out as 23.5 newtons. So that means the resultant force, the change in force, is the difference between these, which is 3.7. And that equals mass times acceleration. So if we can divide through by the mass, if we can divide that 3.7 by the mass, we'll get the acceleration of the drone. Now, they haven't specifically given us the mass. But they did tell us that at 22 meters per second, it is hovering, it is stationary. So at that point, that force is equal to mass times gravity. So if I divide that 19.8 by the force due to gravity, I will get the mass of the drone, which is 2.02 kilograms. And I always ask you, how do you feel about that answer? Could a drone have a weight of about 2 kilograms? Yeah, that sounds about right to me. I've worked out the mass, so I get that resultant force of 3.7, divide through by the mass, 2.02, and I get an acceleration of 1.83 meters per second squared. And just when you think this question is over, it's not. You've got another 7 marks on the next page. Define velocity. Learn it off by heart. It's the rate of change of displacement. Okay, velocity is a vector. It's the rate of change of displacement. So here we have the path of the drone. And it tells us it took 32 seconds to go from A to B. And you can see the total distance it covered is 40 plus 90 plus 10 plus 30 in that 32 seconds. Okay, so it's easy to work out the mean speed. Mean speed is total distance divided by total time. Add them up, 130, 140, 170. Divide by the 32 seconds, 5.3 meters per second. The reason I've done that is because Bill's friend Ted, great movie, Bill and Ted, believe that the mean speed is more than twice the magnitude of the mean velocity, right? And we've got to see if that's right or not. So the mean speed was easy. Add up all the distances, divide by the time, there's the mean speed. Now the mean velocity is the total displacement divided by the total time. And the total displacement is just from A to B. All right, we've got to work out that distance from A to B. That's the total displacement. And the way to do it is to draw an imaginary right-angle triangle and then use a bit of Pythag. So if you think about it, to get from there down to the bottom is 40 plus 10, which is 50. And then to get from there across to there, I've gone this far here, which is 90 take away 30, which is where I got the 60 from. So let me say that again. I'm working out the distance from A to B directly there, the displacement. I'm creating an imaginary right angle triangle, and I'm going to use Pythag then to work that out. From there down to there is 50, 40 plus 10. From there across to there is 60, the 90 take away that 30. Do a bit of Pythag on these numbers. Square add root comes to 78.1 meters. Divide that through by the 32 seconds it took, which gives me a average velocity of 2.4 meters per second. Right? Now the 5.3 is more than double 2.4. So Ted is correct. Happy days. And then the last usual rubbish that they come up with. Drones have many applications in today's society, give one benefit and one risk. Just use your common sense. What's the benefits of drones? Right, well, photography, going down volcanoes and other places that normal human beings can't get to, Amazon are even trying to use them to deliver parcels. And the risks, obviously privacy is a great risk. You could be delivering illegal stuff. And of course you could hit people in the head with them and cause injury, right? They only ask for one of each. I've listed a few there for you to have a look at. Massive question, that 17 marks, basically makes or breaks your paper. But a good 6 or 7 of those marks will just learn off by heart bookwork. So make sure you do. Thanks for sticking through this question. Phew.